In this video, I'm going to show you how you can use the plugin Stardist, so Napari Stardist, to use Stardist within Napari. So let me go back to my data. I'm going to open this file. So it comes from the PlantSeg project. So this is cells from plant. And here, so as we actually installed the bioformat plugin, this image, which is a 2-channel images with 137 planes, 3D image, is when we open it, it's directly open as 2 different channels. Okay, so here we have the nuclei, and here we have the membranes. So to show you how we can use Stardist, I'm going to use a smaller part of this image, but that will work on the whole volume as well. And just to show you, because sometimes it might open it directly as Napari built-ins. I'm going to remove everything here. When you can't open with the plugin that directly take into account the metadata and separate it as different channels, you can go in File and then Open with Plugin, and then open file from there. When you do that, it's gonna take. So I'm gonna use the same image that is cropped. Normally, when you drag and drop, you have this window that pops up. But if you check that, it doesn't pop up anymore. So if bioformats was selected before, it used the bioformat plugins, but it might, you know, sometimes it happens. So we do it not on purpose, or you never know what happened. And so if I use the Napari built-ins and not the bioformats, let me show you what it looks like. You only have one image here with a slide for the channels. So it's not super convenient if you want to look at both channels at the same time. So I'm going to open it again with Open with Plugin, same cropped image. In that case, I check that bioformats is selected, and in that case, I'm going to open the image with 2 different channels. So here they have the same channel. So I told you here, so it also directly takes, uses the additive blending, so you can visualize both channels. So here it doesn't have different colors, so I'm going to change the membranes to, let's say, magenta, and then the nuclei to cyan, for example. And now you can, we can see both different channels at the same time. I can do a 3D reconstruction. It's pretty neat, I would say. So let's go back to 2D. I'm going to focus on the nuclei. I'm going to use the Stardist plugin. So if I go to plugins, I have something which is called Stardist and Stardist Napari between brackets. I can open this plugin. And now I'm going to have all the parameters on the side. So, problems with visualization sometimes, so I can't see all the parameters. So I'm going to try. So here I don't have, so that's, it depends. It might happen to you, it might not happen to you. I don't have a whole list of parameters. I can try to get it, like this, and see if I can see all the parameters. I still can't. I don't have access to the run plugins. So what I'm gonna do is I'm gonna actually close Napari. I'm gonna change visualization to something smaller. So I would, if I do this, no, that's the other way around, sorry, that's smart. Let's go to this, and hopefully now it's gonna work. So I wanted to show it to you because, you know, might have this problem. Sorry, not the right window here. All right, everything is smaller. It's better if you have good eyes or glasses. And now let me open the image again. So the cropped one. It's opening with bioformat, so it's opening it the right way. I'm going to change this again to magenta, this to cyan. I'm going to just look at my nuclei. It's going to be easier. So I could look at it in gray levels as well. I'm going to open the Stardist Napari plugin, and now should be good. You see, now I can see all the parameters. So that's not perfect. You can also actually parameterize the QT. I did that in the past, a long time ago, directly changing QT parameters in the prompt. It's actually easier this way. So now you can see you first choose which channel you want to segment. I should have changed the name actually because it's not super explicit. So I'm going to change it now to nuclei and here membrane. So obviously it's not changed now, but if I close my plugin, open it again, now I'm going to have, you know, the right names. And so here it's nuclei, so that's okay. Then you have the image axis, so that's very important actually because, so for example, if I use a 2D model, here I have lots of different planes. It's not actually a 2D, it's in 3D, but I can actually define, so if I say that this is Z, Y, X, then it's telling me that, you know, there's a discrepancy. It's a 3D volume, I'm using a 2D model type, but can't work. If I say that it's an image sequence, then it works because it's gonna use the 2D model plane per plane. If I want to do it with the 3D model, now I need to define it as ZYX, and you see it's working. So then, so when, you know, classic things, we want to normalize the image with the parameters that you use for training. A nice feature that you don't have in Fiji, for example, a Fiji plugin, but that you can find in QPass, for example, is that you can apply a scaling. So if you're using a model that was trained for a given resolution, for example, and then you have same objects, nuclei, for example, but different resolution, it's not going to work. Deep learning is pretty sensitive to scale. But here you can rescale your image and then it's going to work better. You have, so probability score, overlap threshold, same parameters than you have in the Stardist Fiji plugin. The kind of output you want. So you can have label image or polygons, polyhedra or both. So when you do it in 2D, you can have both in 3D. Polyhedra is not working super well. So I'm just going to use a label image. And then you can also tile your image. This might be, you know, useful when you do 3D images like this to say like, so let me show you how it works. You need to do it with these signs. And then you say how much you want to tile in each direction, say Z, Y, X. So I'm going to say that I want to do like, let's say 5 tiles and then 2 in Y and X. I could do 511, 311. Probably that would work. But I'm going to try this one. And so in my memory, it works a bit better if I increase it. So here I'm going to use the 3D model, which was trained on simulation. So it's it can be successful for some example. Not so much in my experience, but we'll see what we get. The nice thing is that as here we are in Python. So as Napari is in Python, if you train new models, you can directly put, if you use a custom 2D or 3D model, you can directly put the, so when you have this, you need to define where you want to choose your directory. Nice thing is that here, for example, that's a model that I retrained. So here it's not okay because it's a model that was trained on 2D images, but you just give the path to your to the directory where you have everything, and it's gonna work as well. I'm gonna go back here. So it's just to show you that you can do this. You don't need to convert your model, which you need to do with Fiji plugin or QPath plugin, for example. Okay. So here is what we got. So it looks okay. We're missing quite some, so we could decrease. Let's just try when we decrease the probability threshold. So we only have 15 planes, so it's pretty fast. I didn't install the plugin with the GPU, so it's just using my CPU, and it's pretty fast. But with the 3D model, we see that unfortunately doesn't work everywhere. It's gonna, so maybe we'll see that often it also hallucinates nuclei between nuclei. But if you retrain a model on your data, it's very much likely that it's gonna give you good results. And so here the nice thing is that you can directly process your data in 3D, which is not doable with the Fiji plugin, for example. So that might give you an opportunity to use 3D models and directly look at your results. So you see it took a little bit more time because we have more nuclei and it was more work of post-processing. So not too bad. We see that, so here, as I showed you, we can change this parameter and we're going to have the contours. And so that's why having the polygons is not super helpful, except that when you have polygons, you also have the areas where polygons are overlapping. But you can look at the results, and it's actually not that bad, but it's you know, it's probably segmenting things that do not really exist in there. And sometimes, so let me I don't know if I'm going to be able to find hallucinations. Yeah, here it's not. I don't think I think I would have to put a lower threshold. Anyway, again, depending on your images, it could work. Just to show you how to use it. So as I told you, you can also use it. So I'm going to remove the tiling. You can also do it for 2D. So here I think it's known. Yes. 2D, and now I have to tell the plugin it's not a ZYX, but it's a TYX. Nice thing is that you can do it plane per plane, but you can still do the normalization as a whole, which is going to be better here because it's still a 3D volume. And I think I'm going to increase maybe a little bit, and we can try. So now it's processing plane per plane. So you have this log, so you can see where you are within your processing. And here we are. So the post processing is much faster because it's just in 2D. And that's what you get. So it's more sensitive. Is it better? Honestly, you have to evaluate. In my experience, at least the 3D model is not extremely well suited to most real images, which doesn't mean that if you don't retrain it, you will have bad results or unsatisfying results. And here we chose the match to previous frame. It means that for example, let's focus on this nucleus. From one plane to the other, it's the same color. It's considered as the same nucleus. So at least, you know, it's just overlap. So problem with this kind of things is that if you have two nuclei that are on top of each other in the z direction, you're going to do some mistakes. Then you can also think about some post-processing or things to improve your actual segmentation.